Okay, so I ask you to pause this, try it. So you should graph this using graphing calculator. Then your graphing calculator would look something like this. Then you are looking at domain. What is the domain? Same thing. It's not connected at x equal to 0 right here. You see this curve, that curve, they are not connected to each other. And that split happens at x equal to 0 right here. So what is the domain? X cannot equal to 0 is the domain. Okay? You have to write that as an interval notation though. So you can write a number line like that, just like a previous question. X cannot equal to 0. It can be anything on the left, anything on the right. So this is how you write interval notation for domain. If you look at the range, we have horizontal asymptote here. What does that mean? Graph keeps approaching, approaching, approaching. It will never touch x-axis. Same thing here. Keep approach, approach, approach. It will never touch x-axis. So if I ask you how low does the graph cover, it covers forever to the down, forever to the up, but there's a one missing value of y right here. Y cannot equal to 0. Okay, so range would be y cannot equal to 0, just like this. Okay, and you do interval notation about the y, you end up exactly the same answer because y cannot equal to 0, minus infinity to 0, union 0 to infinity. So range will be just like that. Again, no intercept. It doesn't touch x-axis, it doesn't touch y-axis, no x-intercept. Left hand, as you keep going to the left, 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 it approaches to 0. Okay? As you keep going to the right, it approaches to 0. So left hand is 0, right hand is also 0. Infinite discontinuity at x equal to 0. So right here we have this connection. Now, as you go to the right, what happened to the y? Decreases. So here through here decreases. Minus infinity to 0, decrease. Also here, as you go to the right, also decreases here. 0 through infinity also decrease. Decrease here, decrease here. Okay, so it's decreasing both. Okay, radical functions. So if you have a nth root of x, depending on n, if n is even, you will have something going on only right hand side of the x-axis, y-axis on it. So if n is even, you will have a graph something like on the right hand side only. If n is odd, you will have left and right both direction. So example of this graph would be square root of x, fourth root of x, sixth root of x, and so forth. Example of this would be cubic root of x, fifth root of x, seventh root of x, and so forth. You will have graph left and right like this. Okay, graph and analyze this. So here's one thing. Let's say I ask you to do this without graphing calculator. Here's what you can do. X to the m over n the power is exactly same as nth root of x to the m power. That's exactly the same as this. Okay? So when you try to sketch this without using graphing calculator, what matter is n value. N value. So what am I saying? This is exactly same writing as fourth root of x to the fifth power. That's same as this. What matters here? This guy. Okay? If that's even, we only have right action. If that's odd, we have a both action, like both left and right, it covers everywhere. So all I look at is this fourth root, that's even. So all I can say, I know something's going on the right. Nothing's going on the left. That I can tell. Okay? So if you graph using graphing calculator, so this one, you are kind of going up, okay? But all I'm saying is we have some action on the right. So this kind of action, it's kind of going up, it's kind of going, that's not that significant. As long as you have some graph going to the right, that will take care of everything else here. Okay? So I'm more focusing on bigger picture without graphing calculator. As long as you can kind of know graph or something like that, that variation shouldn't matter much. Okay, so if you use a graphing calculator, this is more precise graph and domain, only right hand side. As left as you can get is 0 through, you can go right forever, 0, comma, infinity, 0, we have solid dot here, so 0 is a bracket. Range means low, as low as you can go to 0, infinity. Solid bracket as well. X-intercept, Y-intercept, both of them is 0. It touches x-axis, touches y-axis. Okay, there is no left-hand behavior here. It's terminated here. So left hand, we don't talk about it. This is the right hand. X approach to the positive infinity, right hand. As you go to the right, what happened to the y? What happened to the y? Y goes up, so it goes in positive infinity. It's a continuous on right hand side, continuous on 0, comma, infinity. Increasing 0, comma, infinity. Yes, this is not correct. 0, comma, infinity. You never use bracket on increasing, decreasing constant. Okay? Increase, 0 through infinity. Okay? Pause the video, please. You try this. Here's what I can say. This is exactly same writing as third root of actually second power. One number matters when you roughly sketch it, this number. If that's odd, you will have both actions. So I know, roughly, I know graph would look something like this. There's no. Yeah, if you graph this using graphing calculator, you would have shape something like this. Okay? And they're asking continue. It's continuous everywhere. All real number, continuous everywhere. Done. Pause the video. Please try. Again, this is exactly same writing as square root of actually third power. You put 2 here, that's okay, but square root, usually we don't write 2. So once you write like that, all matter is one number is that, 2. 2 is even. How does that matter? Even, you only have action on the right. So all I can say is if you roughly sketch it, it's gonna be something like this. Without using graphing calculator. If you say, Wilson, can I just type into the calculator and look at it? Of course you can do it. But many times I ask you this kind of a question without providing graphing calculator. I say, no graphing calculator, do that by hand. Then you need to know how to deal with this using that property. So it's a continuous, 0 or infinity. Continuous, you have to say bracket because it's solid dot. Continuous, yes, this is the correct answer. Increasing, decreasing, constant, that's the one you don't use a bracket. But continuous, this is the answer, not this. Graph and analyze this. Okay, this one has more into it. Okay, so if you have graphing calculator available, you can put that into the graphing calculator and do it. it's very possible for me to say no graphing calculator and do that without graphing calculator. Then it becomes a little bit of a work. So here's what you would have to do without graphing calculator. Here, 3x minus 4, you have to factor out 3. So if you have a factor out 3 here, you will have this, then it's clear. So here's what you can do. So from fifth root of x, this is the beginning. And you should know fifth root should be odd. So you have a both. Okay. So this one, you have graph something like this. From there, 3 times x. So you do the fifth root of 3 times x. So that's what? Horizontal shrink by 1/3. So you're going to squeeze this horizontally. Okay? So it will be something like that. Then 1/2 outside, it will be vertically shrink by 1/2. So it will be squeezed a little bit, something like that, but it's still like this. Now this guy, which is going to be moving right by 4/3. So your overall shape will be something like this. Okay? So that's a rough sketch of it. So if you have a graphing calculator, and if I let you use your graphing calculator, just type it in, then you get the graph of this. And you look at the graph, and you can answer all those. Domain. It's going left and right, whatever. It's not missing any value. It covers everywhere. So domain or real number. Minus infinity to infinity. Range. If you look at it, keeps going down, keeps going up. It covers everywhere. All real number. Minus infinity to infinity. X-intercept. If you look at it, x-intercept is passing through right there, which is a 4/3. So you might say, well, how am I supposed to know it's a 4/3? Again, x-intercept algebraically, you could have plugged it in y as 0. This is y. Then you can solve for x. You're trying to find x-intercept. Okay? Plug in y is 0, solve for x. Multiply by 2 both sides. How do you get the fifth root? You take a 5 power, take a fifth power, 0 to the fifth power, 0 times, 5 times, it's got to be 0. Fifth power, fifth root disappears. Solve for x, plus 4 both sides. Divide by 3, divide by 3, 4/3 is x. So that's how you find x-intercept. Plug it in y is 0, solve for x. So you got a y-intercept, x-intercept I mean. Y-intercept. Y-intercept is some decimal here. So y-intercept will be plugged in x as 0. So finding y-intercept, plug it in x as 0. So y equal to 1/2, fifth root of, plug it in 3 times x, which is 0. So y equal to 1/2, fifth root of 3 times 0 is 0. 0 minus 4 is minus 4. So if I say no calculator, you're done here. You cannot do much more without graphing calculator. If you have a graphing calculator, just put that into the graphing calculator. You got some decimal value, which is this, y-intercept. Okay, as you go to the left, what happened to the graph? Keeps going down, minus infinity. As you go to the right, keeps going up, positive infinity. Continuous everywhere. Continuous for all real number. All connected. Now, as you move to the right, what happened to the y? Increase, 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 increase. As you move to the right, increase, increase, increase everywhere. Increasing everywhere. Minus infinity to infinity. Okay. Let's stop here.